Alright, welcome back. So picking up from last time where we queried for our swap chain support and went through to make sure that the present modes and the formats were available, the ones that we expected. And now we are going to have to scroll down to where we left off. So we queried the details of the swap chains. Yep, we did all this. Here we go. Choosing the right settings for the swap chain. So let's just dive right on in. Music's kind of decent volume. Cheers. Alright, so if the swap chain adequate conditions were met, then the support is definitely sufficient, but there may be there still may be some different modes of varying optimality. I don't think I've ever read that word before. We'll now write a couple of functions to find the right settings for the best possible swap chain. There are three types of settings to determine: surface format, which is the color depth; presentation mode, which is conditions for swapping images to the screen; and swap extent, which is the resolution of the images in the swap chain. Okay, let's check this out then. So for each of these settings, we'll have an ideal value in mind that we'll go for if it's available. Otherwise, we'll create some logic to find the next best thing. Sounds good. Surface format. The function for this setting starts out like this. We'll later pass the formats member of the swap chain support details struct as argument. Choose swap surface format. Alright, and it takes in all this jazz. Each surface format, VK surface format KHR entry contains a format and a color scheme member. The format member specifies the color channel and types. For example, VK format B8, I'm not reading all that, means that we store the BGR and alpha channels in that order with an 8-bit unsigned integer for the total of 32 bits per pixel. Okay, yeah, so 8 times 4, yeah. Okay, the color scheme member indicates if the sRGB color space is supported or not using the struct flag. Note that this flag used to be called something else, okay? For the color space, we will use sRGB if it is available because it results in more accurate perceived colors. Interesting. It's also pretty much the standard color space for images, like the textures we will use later on. Because of that, we should also use an sRGB color format, of which one of the most common ones is VK format. Okay, let's go through the list and see if the preferred combination is available. All right, so let's create another function, and we're gonna. Where are we gonna put it? Somewhere above our rate function and our swap chain querying. Let's actually do it below here. Right, so we've got this choose swap surface format. Takes in a const, not that, it's a list. It's an array of these VK surface format KHRs. It's called available formats. And that's going to come from our struct here, this one here, because I believe that's the same as that. Yeah. Okay, so within here, we want to loop through our available formats. Okay. But we also need our available format count, which we have on the struct as well. So let's pass that 38. Don't know why it's const. I don't think it is. I'm going to delete that for now. The U32 of count format, and then I'm just going to call this formats. No, I'll keep it as available formats. It kind of makes sense, I suppose. So for U32, I equal to 0 while I is less than format count, and I plus it. We want to say if available format is equal to VK format blah blah blah. Kind of want to say Barbara for some reason. If available formats at position I is equal to, and now I think it's going to be a string comparison function. So let's go for it. It's strcmp. We have that guy dot format vk surface format. Oh, so format must be on this. Okay. And the second argument is going to be this macro. What do they call it? Something. So those two are equal, and then that would equal 0. And the second check being if available format.color space equals this, and strcmp, I think it probably is another one. So that's the thing. Available formats position I dot color space and this. Then now then, why are you complaining? Passing argument 2 string compare makes pointer from integer without a cast. Is that an integer? Do I have to use the address? No, it's not. I don't know. Perhaps this is not quite right. What's that error? Incompatible type for argument 1 of string. Ah, so this format is something else. Let's take a look at what these actually are. Has anybody got a link to one of these we can take a look at? I'm going to have to dive into these docs, which could take a while to load because, I don't know, it doesn't. Damn. Let's Google it. Somebody's got a, here we go, registry Chronos. I would love some actual docs, but maybe these are them. Yes, here we go. Format is of type VK format. So maybe we can just do a double equals and see if that works. Okay, let's just try that. So if that double equals this, and then we don't need that check. Don't need 2 of those either. Let's double equals these guys as well. Where the hell am I going there? Now, one of them's right, one of them's not. VK color space KHR isn't correct, it seems. Compression between VK color space KHR and enum. Oh, so right. So do we have to cast that as something else? Selecting a surface. Ooh, let's see what this Stack Overflow. Always a great choice. What's the space problem? The function, yes, returns a list of supported surface formats. Look at the given device. Yep, that's the thing we just looked at. That's the structure. When creating a subject for the surface, you must select the required VK format and VK color space KHR in there. Yep. And these must match. This is example implementation. The set that selects a VK surface format from the multiple thingamajigs. Yep. In a way that is reasonably oh, this person's already a problem. It's just like, is this implementation correct? There is no typical algorithm. Oh, damn. Oh man, why do I keep click happy? You should exercise the same discretion when choosing a format that you would have chosen a physical device. Alright. Oh, they do have samples on Luna G. Formats. Is this? No. Okay. So their example is the format count 1? The format equals another macro and the input of format, but then are they looking at a color? I want you to compare this. Non-linear KHR. Now then, that's not the same thing. Alright. I want to find out what this thing is then. Because I don't think casting it as a VK color space KHR is going to be a good idea. VK color space KHR. It works, but it's not great. Well, I want to know what that is. Luna G, help me out. Help me out. Okay, the cast seems to work. Pretty sure it's a terrible idea, but let's carry on as if it's not. Lies, lies from Tiny Eyes. Return available format. Oh, that's the wrong thing entirely. We're just going to return available formats at position I. Okay. Otherwise, it's going to return nothing, I suppose, are we? If that also fails, then we could start ranking the available formats based on how good they are. But in most cases, it's okay to just settle with the first format that you specify with. Okay. Alright. Choose. But okay, in order to just allow this to work, I'm gonna just say if things go south and we can't find anything, just return the first one, which hopefully exists. It's not liking that at all, is it? Statement with no effect, because you need to return it. The doy. Okay, next one. VK surface format is the same sort of deal, but it's without surface. I'll just copy that and I'll DC++erize it. Okay. Again, it ain't going to be no const, and it's going to be a pointer. Is available format correct? Oh no, I just copied the whole bloody thing. Oh, they also did the same thing at the end, just returning the first one. Wow. That, ladies and gentlemen, is why you shouldn't just copy and paste blindly, and that's why Stack Overflow is not a good resource, really. Not that good of a resource. Presentation mode. The presentation mode is arguably the most important setting for the swap chain because it represents the actual conditions for showing images to the screen. There are 4 possible modes available in Vulkan. Present mode immediate, present mode FIFO, present mode FIFO relaxed, like the sound of that. Present mode mailbox. Isn't that just going to be FIFO? First in, first out? This subdomain is another variation of the second, of FIFO. Instead of blocking the application when the queue is full, the images are there that are already queued are simply replaced with the newer ones. Oh, okay. This mode can be used to render frames as fast as possible while still avoiding tearing, resulting in fewer latency issues than standard vsync. This is commonly known as triple buffering. Although existence of 3 buffers alone does not necessarily mean that the frame rate is unlocked. Okay. Only the VK present mode FIFO KHR mode is guaranteed to be available. So we'll again have to write a function that looks for the best mode that is available. Okay, this is what I thought I was copying. Should never assume, although it is useful for survival. KHR, choose swap present mode. And it's going to take in a list of VK present mode KHRs. I'm going to call that available present modes. SENT modes. And we're going to also want the same as before, a U32 of what do we call that? Present mode count. Oops. Alright. Let's just return VK copy and paste. Although, what did I just say? Oh, I said didn't copy, that's teaching me. present mode FIFO KHR. Okay, so in this function, I personally think that the VK present mode mailbox KHR is a very nice trade-off of if energy usage is not a concern. Should it often be a bit of a concern because doesn't that sort of tie to performance? It allows us to avoid tearing while still maintaining a fairly low latency by rendering, by rendering new images that are up to date, as up to date as possible, right into the vertical blank. In mobile devices, where energy usage is more important, you will probably want to use VK present FIFO instead. Okay, now let's look through the list to see if VK present mode mailbox is available. Alright, same. I'm just going to do this because I already wrote it moments ago. So this one's guaranteed apparently to be available, so that's the default. Okay, for each one of those, we want to say if available present modes equals VK present mode mailbox KHR. Then head on out and live your best life and return that particular one. It's gonna have to be either, isn't it? Alright, excellent. There's our default as well. I'll do a quick compile and see what happens. Build and game. We're not even calling the function, but at least there's no major problems. Okay, swap extent. I don't remember what time I started this, but let's just carry on a little bit longer. VK present, we just did that. Swap extent, that leaves only one major property for which we'll add to the last function. Okay, so our VK extent to D is choose swap chain extent. Ba-boom. Oh, let's copy that thing. What's that? Oh. The swap extent is the resolution of the swap chain images that is almost always exactly equal to the resolution of the window that we're rendering to in pixels. More on that in a moment. Is this a podcast or something? The range of the possible resolutions is defined in the VK surface capabilities KHR structure. Vulkan tells us to match the resolution of the window by setting the window width and height in the current extent member. However, some window managers do allow us to differ here, and this is indicated by setting the width and height in current extent. Okay. Current extent to a special value. Sorry, keep on reading, it helps. The maximum value of U in 32. Right, okay, so we set it to the max value of U in 32. That ends up being a bit different somehow. Alright, in that case, we'll pick the resolution and that best matches the window within the minimum image extent and the maximum image extent bounds. But we must specify the resolution in the correct unit. Oh, so it's not always pixels. GLFW uses 2 units when measuring pixels and screen coordinates. For example, the resolution width and height that we specified earlier when creating the window, which we put as constants at the top of the file, that is measured in screen coordinates. But Vulkan works with pixels, so the swap chain extent must be specified in pixels as well. Unfortunately, if you are using a high DPI display, screen coordinates don't correspond to pixels. No, they do not. Instead, due to the higher pixel density, the resolution of the window in pixels will be larger than the resolution in screen coordinates. Yeah, bummer. So you have to know that ratio and hope that it's exactly square. So if Vulkan doesn't fix the swap extent for us, if Vulkan doesn't fix the swap extent for us, we can't just use the original width and height because they're going to be screen coordinates. Instead, we must use GLFW get frame buffer size to query the resolution of the window in pixels before matching it against the minimum and maximum image extent. So why don't we just do that from the get-go? All right. So in this code, we are doing the same setup, looping through all the capabilities. And we're not doing that at all, just made that up. Capabilities are current extent. The width does not equal the numeric limits of, well, that particular size. Oh, how do we get that in C? That's going to be a new learning. If they don't equal that, then we return the current extent. Okay. Otherwise, we get the width and height from the GLW function, set and create a new struct of the actual extents, and then clamp it the width and height, passing in the width as the minimum. Oh, okay, so the clamp, we get the GLW sizes and then we just put a minimax on it. That's what the clamping function is doing. Okay. I wonder if that would end up doing any kind of distorting. I don't know. Okay. Let's just continue on. I'll just copy this and then I'm going to, as I've been doing, DC++ing it. So let's go with, that was a const to the capabilities, but we actually didn't make it a const when we created it up here. So it's just going to be as it is. But I think we might need, what's the ampersand at the end of the type for? Oh, that's weird. I'm just going to leave that as it is. I'll make it a pointer. Will I? No. Alright, capabilities dot current extent dot width does not equal. How do we get the numeric limits of U in 32? C, oh, bummer. C, get numeric of type. Now you see, that's C++. C number of interface. How do we get the limit data up to C? Guess Stack Overflow might help after all. Oh, we do have to have a limits.h include. Let's look up limits.h. I want to know. Oh no, this. Oh well, we're on this one. C++.com. Maybe it's going to be the same thing. So we could do, if we know it's a U32. No. I'm going to go back to here. Let's first include our limits. Limits.h. And our U32, was it? A UN32, yep. So we want to know the limit of that, which would probably be a UN max. I'm gonna just go, yeah, I reckon it's gonna be that. Yeah. So if that is not equal to U int max, yep, let me return that. Otherwise, where do we get the, oh, this is the top win width, I reckons. Perhaps it's not. Where is that window? Oh, it's a window, so we have to pass in the app window. Alright, p app. So we are going to be passing in an abstract and a pointer to p app. Although we can actually skip doing that because I think the only thing we need from that is the window. Let's just pass in the window. Yeah, let's do that. Which is going to be of type. Where's my app? There's my app. This. window. Passing in our window and our capabilities. There's our UInt max, we're comparing that, and then this width and height. Oh, these are being set here, okay. And this would be static cast. I wonder if we can. Yeah, okay. It's just width and height, like that. Yep, I believe that's probably right. Do I need to do a static cast? I don't think, because I mean, let's Google this function to see what it returns. The GLW reference, please. Sounds like I was ordering a cab, or where to go in the cab. Here we go. What are you returning? You're returning 2 ints. So yes, no, that's taken in 2 ints. Sorry. Oh, they're ints initially. Oh, don't like that, but okay. They're ints initially. Could we make them U32? No. Alright, make them ints, and then we will cast them as U32s. Okay, U32s all round. And the actual extent, the width is equal to the clamp of this and this and this. So, what type is that? Does C have an inbuilt clamp in the standard library? C clamp function. C language clamp function. Fastest way to clamp a reel. An algorithm to clamp a value between a pair boundary. OpenSTD. What's that? Go back quick and then go to this one. Well, that's C++. So, thanks for that. The proposed wording. C++. Soz. Ugh. Double clamp. Yeah, okay, I can just write my own. Screw it. Alright. I shall do that. Close all that. Let's just chuck it here for now. What is it going to be returning? U32s. It's very specific. It's not. There's no function of loading or polymorphism going on here. I'm just going to say U32 clamp because, although let's call it clamp U32, just because. Hey, it's my function. I'm gonna name it whatever I like. I'm probably gonna regret it, but you never know. It takes in 3 things. First one's U32. That is let's call it a number. Oh, actually call it n because it's a number. And there is gonna be the min and the max. Min, max. And what are we doing? We're expecting it to return that. So they can all be copies, doesn't really matter. Alright, so if n is greater than or equal, less than or equal to min. Actually, if it's less than min, return min. If it is more than max, return max or max, otherwise return n. That makes sense, doesn't it? Yeah. If it's less than the minimum, return the minimum. If it's more than the maximum, return the maximum. Alright. I mean, I know that there's there's inherent vulnerabilities in just comparing numbers like that, because you can do some funky stuff. I believe there's some kind of undefined behavior possible, but in our little tiny clamp function, I think we're probably going to be alright. Or at least we're not playing with giant numbers here. Or unless someone's got an absolutely massive screen, in which case more power to you, buddy. Right, here's our versions of the clamps. Then we're returning the actual extent, and I think that looks fine. Let's put this as a utility function. If it works. Down here. And I'm going to move this to here. Just to the very bottom. Because I don't need it to be cluttering up the space we're looking at. Alright. Done, 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 done. Now, the clamp function takes a bounds, yes. That's fine. Let's compile. Errors, there are none. But we're also not calling this function. But let's do the creation of the swap chain in the next video because this is getting a bit long. So until then,